Welcome all. In the last video, we have discussed about the radius of electrons uh, according to the Bohr model of atom. In this video, we shall be discussing about the energy levels of electrons in a hydrogen atom. We will be discussing about the permitted energy levels. Please note that electron cannot possess any energy. Instead, it can possess only certain energy levels which are basically quantized. Okay, so we actually uh, had some results. We'll just recall them. We have an equation for the speed v us e divided by square root of 4 pi epsilon 0 mr, and we had another result for the radius Rn equals n square into h square epsilon 0 divided by pi m e square. So these are the two results we already had. Now we are going to consider the energy of an electron which is revolving around the nucleus, which is a positively charged quantity having charge plus E. The electron is revolving, so this is basically a negatively charged particle. The radius is Rn and is given by this formula. Now we know that since the electron is revolving with some speed, they possess kinetic energy, and that is given by half m v square. That is equal to we already have equation for v. Squaring, you will have one e square in the numerator, then in the denominator 4 pi epsilon 0 mr. Since it is Rn, nth radius, I am going to stress that. Now I have to multiply that with m and 1 by 2, so 2 into. So that gives readily m e square divided by 8 pi epsilon 0 m Rn. So this is the kinetic energy, and this Rn is given by this formula. So we'll substitute at the end point. So this is the kinetic energy. Since there is an electrostatic force between the two, that is nucleus and the electron, there will be electrostatic potential energy. Okay, since electrostatic force is conservative, so that is given by the formula 1 by 4 pi epsilon 0 q1 q2 divided by the separation R. So in this case, q1 is plus E and q2 is minus E. So plus E into minus E q1 q2 divided by 4 pi epsilon 0 Rn. So you can write it as negative oh, we made one severe mistake. Actually, there are two m's. We have to cancel that in the previous step. We have to cancel this m and m, so that there won't be m in the numerator and denominator. So I'm going to erase them. Okay, so let me write Rn closer. Okay, right. So this is negative E square divided by 4 pi epsilon 0 Rn. Now the total energy is nothing but kinetic energy plus potential energy, correct? That is E square divided by 8 pi epsilon 0 Rn plus negative E square divided by 4 pi epsilon 0 Rn. Upon simplification, we'll get it as negative E square divided by 8 pi epsilon 0 Rn. And please note that this Rn is given by the formula, by this formula, correct? So this is the formula. Rn is given by this particular formula, right? Okay, fine. So we have the final formula, and please note 2-3 points. It worth noting 2-3 points. Please note that numerically kinetic energy and total energies are equal. Both are E square divided by 8 pi epsilon 0 Rn. So kinetic energy and total energy are numerically same. And please note that that is numerically equal to the half of potential energy, correct? So that means kinetic energy, total energy and potential energy are related according to this relation. That means if you know any one of this energy, you can very easily calculate the other two forms of energy. Fine. For instance, if your potential energy is x, then kinetic energy is half x. And if your kinetic energy is some 10 unit, then the potential energy is some 20 units, obviously, numerically. Now, regarding the sign, that's also really important. And I'm giving the sign of kinetic energy, and that will be positive always. And you need not worry about that, because kinetic energy will be positive always. Now, let us consider the potential energy. So I told you that this potential energy is due to the electrostatic force of attraction between the two, namely the nucleus and the electron. So if the force is attractive, then the potential energy will be negative. So potential energy is obviously negative, and this is because the force is attractive. Because the force is attractive. Correct. Now the total energy. The sign of the total energy must be negative since our state is bound. So if the electron is free, its energy will be either 0 or positive. Since this electron is bounded electron, its energy must be negative. So this is really important. You must remember what is the sign and how the magnitudes are related to each other. Okay, so we already had the equation for total energy in the nth orbit as some negative E square divided by 8 pi epsilon 0 Rn, correct? Okay, and we already have another formula, that is Rn is equal to n square h square epsilon 0 divided by pi m E square. Substituting the value of Rn in this energy, will get, so we have this expression, so but Rn is this one, so therefore I can write En as En equal to negative E square divided by 8 pi epsilon 0. I'm going to substitute for Rn. Rn is n square h square epsilon 0. So everything divided by, so that goes to the numerator, pi m E square. So simplifying, you can cancel some common terms. So you can see pi on numerator and denominators. Okay, then I'm going to simplify. I'm going to simplify and write the result as negative, when m is there in the numerator, then e square into e square will give you e raised to 4. So negative m e raised to 4 divided by, then 8 is there, 8, then h square, then epsilon 0 into epsilon 0, that is epsilon 0 square, then some n square. Correct. So this is the energy. So finally I could write the total energy in the nth orbit En is given by 1 by n square into negative me raised to 4 divided by 8 h square epsilon 0 square. So this is our formula. You can see that the energy is inversely proportional to n square numerically, and please note that it is negative. That means as n increases, it becomes less negative. That means energy increases. Correct? Fine. Okay. Now, if you substitute n equal to 1, if you put n is equal to 1, if you put n is equal to 1 here, you will get E1 as negative m e raised to 4 divided by 8 h square epsilon 0 square. You can see that everything is constant. Upon simplifying, you will get it as negative 2.18 into 10 raised to negative 18 joule. Usually in the atomic domain, in the atomic domain, energies of electrons are represented in eV, electron volt. So in eV it is negative 13.6 eV, 13.6 eV. Correct? Hope you remember the conversion. 1 eV is nothing but energy required to take one electron to a point of potential difference 1 volt. That is 1.6 into 10 raised to negative 19 joule. This is 1 eV. Correct? So if you divide this with the 1.6 into 10 raised to negative 19, you will get it as 13.6 eV. And you can write the energy of the nth orbit as En is equal to this constant E1 divided by n square. So it is inversely proportional to n square. Or alternately, you may write En is equal to some negative 13.6 eV divided by n square. Since n is in the denominator, you may think that as n increases, energy decreases. But you must be very careful with this negative sign. So that means numerically the value decreases, but it becomes less negative. That means it keep on increasing. Okay. So the electron can have only these energies. If you put n is equal to 1, you can have 13.6 eV. If you put n is equal to 2, then 13.6 divided by 4. That is roughly some 3. Then negative 13.6 divided by 9 for n is equal to 3, like that. Okay, so let us consider the possible energies. En is given by negative 13.6 eV divided by n square. So let us just tabulate the value of n versus En. For n equal to 1, it is negative 13.6 eV. For n is equal to 2, negative 13.6 divided by 4. So that is negative 3.4 eV. And if you put it as some 3, then it is negative 13.6 divided by 3 square, that is 9. It is roughly 1.5, negative 1.5111, etc. Now for n equal to 4, it will be negative 13.6 divided by 16, that is negative 0.85. So just let us visualize these energy levels. So let us plot some energy levels. Say this is some 0, then we have to plot up to negative 13.6. so let it be some negative 2, some negative 4, negative 6, everything is in EV, negative 8, negative 10, then some negative 12, some negative 14. So this is enough. So on this axis we represent the energy, correct? And let's plot the graph. So first let us consider the ground state, that is n equal to 1. So n equal to 1 is called ground state energy. So it is some negative 13.6. So negative 13 will be somewhere here, then negative 13.6 will be somewhere here. So this is n equal to 1. So this is the energy corresponding to n equal to 1. Now for n equal to 2, it's negative some 3.4, correct? So negative 3 is somewhere here, so negative 3.4 will be somewhere here. So this is the energy corresponding to n equal to 2. It is negative 13.6. We call this as the first excited state. First excited state. We call this as the ground state. We also call this as first permitted state. This we call it as second permitted state, correct? Now for n equal to 3, it is somewhere at 1.5, negative 1.5. so this corresponds to negative 1, so negative 1.5 may be somewhere here. So this is for n equal to 3. We call it as second excited state. Second excited state. We also call it as third permitted state or permitted energy level, correct? Now let's consider the next energy level, that is n equal to 4. So that is somewhere at 0.85. so if you call this as negative 1, then it is somewhere here. You can see that the energy levels become more closer. Okay, now if you put n is equal to 5, then the result will be negative 13.6 divided by, so if you consider n equal to 5, then it will be negative 13.6 divided by 25, that is just 0.544. so if you consider that graphically, it will be somewhere here, 0.85 and 0.5 are much closer. So this is the energy corresponding to n equal to 5. So please note that the energy levels are not equally spaced. Okay, so the energy difference between n equal to 1 and n equal to 2 is roughly 10, correct? 13.6 and 3.4, roughly 10. 10 eV of energy is the difference between the ground state and first excited state. However, from the energy difference between n equal to 2 and n equal to 3 is this much, roughly some 1.4, 1.3.4, no, 1.9, roughly 1.9 eV. So for the first two, it is roughly 10 eV, but for the next it is roughly 2 eV or and between the next two it is roughly some 0.8 some eV, like that. So please note that the differences uh, become less and less, or the spacing between the energy levels decreases with n, with increase in n. Correct. Thank you. In the next video we shall be discussing about the hydrogen spectra.